Our workshop series on exposed secrets. First things first, my name is Gautam Neerukonda. I'm currently working as a solutions engineer at JFrog. My role here is to talk to customers every day, understand their initiatives around securing their software supply chain and providing them with best practices and how they can leverage the JFrog platform to address their security needs. Now, today's topic is going to be about what are the growing trends in exposed secrets as a part of your software supply chain, and why is it important to secure your organization by protecting these secrets. We look at a live demo of a JFrog platform and see how the JFrog platform will be able to detect this sensitive information within your binaries, and we'll also see the remediation techniques and best practices that our security research team provides as a part of the alert notification process. So let's take a look at what is your software supply chain. There are a lot of official definitions out there, but I would like to use this animation to talk about it. So a lot of times the open source public contributors basically publish various sets of dependencies or libraries that can be helpful for you to develop software faster and efficiently. And they publish these binaries into a commonly known popular public registry. Your developers, on the other hand, consume these dependencies, embed their own sets of proprietary source code or business logic by using or leveraging these public dependencies, produce a custom proprietary binary specific to your organization, wherein you store these artifacts in a certain artifact registry like JFrog Artifactory. And you perform multiple sets of builds, tests, and finally release the given software package to your production or to your distribution networks so that your end production servers or your customers can leverage these software artifacts and run the application that you have produced. Now, when it comes to securing your software supply chain, you should look at every aspect of it. And most of the time, the open source dependencies that you are relying on are the primary sources of compromise, because of the fact that these are widely adopted and the attack techniques associated with these open source libraries are commonly available for the attackers to share among themselves and compromise these enterprise assets at a large scale. So the impact radius is very high. Now, coming to today's topic, what is a secret? It can be a sensitive piece of information like an API key, password, or a credential that can provide access to very confidential information like your database, like your compute instance where your application is running, which can allow a certain unknown party access to this information, and they can share this information to others as well as gain persistent presence within your corporate infrastructure by using these credentials. And at the same time, no matter how many sets of firewall solution, whitelisting solutions that you might have in your organization, once a sensitive API key or credential is compromised, it serves as an express route for the attacker to gain access to the information or corporate assets. Now, when it comes to these secrets, you can see as an example, I have a table listed down here, the various public cloud platforms or tool sets and the example token patterns that they follow. So it's quite easier for an attacker to scan through multiple publicly available registries or information points or Confluence documents or your Git repositories for certain publicly available libraries to scan for these patterns and figure out if there's a sensitive information or an API key that is exposed knowingly or unknowingly by your developers. Right? Now, you might be wondering, what is it that I need to be concerned about? My developers are following all the best practices. I don't think I need to be worried about this. So looking at the various public registries and the millions of artifacts that we have scanned, again, if you're interested in this research article, we'll be posting them in the chat. You can read more about it. These are the distribution of various types of artifacts that we have scanned through the public registries, and surprisingly there are hundreds and thousands of active and inactive tokens that are found in these artifacts. And this is publicly available information, as I said. Any skipped kiddie or a young attacker can gain access to these the key patterns, scan by using some crawlers, and gain access to your sensitive information. That's where it's pretty easy to detect these tokens, and this is where I'm going to switch towards why is it important to efficiently manage your secrets. One of the biggest data breach was detected in the history, wherein 1 billion PII records got compromised as a part of this breach. So it doesn't matter how complicated your network infrastructure, how complicated your security teams are enforcing in terms of encryption technology, or the key combination requirements to have special characters or caps and numbers. If the combination of the lock is written on the door, it's a no-brainer that the entire organization comes to a compromise, or the entire organization's assets will be compromised. So again, just scanning the source code is not good enough. There are instances in which there are certain environment variables that contain the secret. There are some instances in which a certain developer might have embedded a text file with all the credentials, and supposedly planning to use those text files to quickly perform the testing in their QA environments or integration environments, but they forgot to remove these files when they ship the artifact to production. Or by mistake commit these source code into the version control system unknowingly. So this is where the responsibility to protect the data that provides the access to the foreign machines to the access to the data is really important. The risk that is associated with providing the access delegation is very high, so you need to responsibly protect the data for the same reason. Now we will switch to the demo unit and see one of the sample alert that has been detected. Here I'm analyzing a Docker container image, and you can see that under the security issues secrets tab, I have various plain text API keys found, weak encryption passwords found, as well as a hard-coded random buffer that was found. And there are multiple information points that we provide through our in-depth security research analysis that our dedicated research team provides. Unlike the other publicly available resources, we provide the steps to remediate these compromised access tokens as well. Before we come back to this, I'll be switching back to the demo unit shortly. If you're wondering, hey, all this is interesting, I would like to get my hands on to this technology and try this on my own containers and see if there are any tokens or API keys embedded in them. If so, you can use this link to start free with JFrog platform. We are pasting this link in the chat as well. You can click on the link and provision your own testbed of a JFrog cloud instance in your preferred cloud provider and cloud region. We provide our SaaS in GCP, Azure, and AWS. You can select the preferred cloud provider and the preferred cloud region where you want your SaaS instance to be deployed under. Even we also have self-managed subscription that is available. Keep in mind, we are the only DevOps platform that supports multi-cloud as well as hybrid platforms. Something to take a note of. Now, once you subscribe for your own JFrog Cloud Platform instance, you can log in into the platform using the credentials provided. The first thing that you need to get started with is by using the quick setup menu option here. It provides a quick utility to provision the set of repositories that you will need to within the Artifactory platform to publish your proprietary artifacts as well as to resolve the commonly used dependencies from the public registries. So here I'm selecting the RPM technology for the quick setup. Immediately it will create three sets of repositories for me. A local repo where I can store my proprietary artifacts under, a remote repository that is proxy caching the popularly known RPM registry, which is mirror.centos.org, and a virtual repo that aggregates the local and remote into a single URL. So this will be easier for your teams to onboard the tool, and we also suggest you to use a team-specific repository. For example, this is for my front-end application team. So once I click the create button, all the 3 sets of repositories will be created. And here you can also see the set me up utility that is providing the package client specific configuration that can help you get started with utilizing the Artifactory repository. Here, it gives you the step-by-step instructions to configure your packaging client, yum client, to work with Artifactory registry. So you can use these commands to publish artifacts as well as resolve artifacts from Artifactory rather than directly pointing to the internet. So here we are streamlining the source of truth by utilizing the Artifactory to proxy cache the public registries. Now, for today's session, we'll be focusing mainly on the Docker repositories. And if I click on the set me up, you can see we provide very native command, Docker login, to the specific JFrog Cloud platform that you have access to. And we have the specific commands that you can follow to push your proprietary Docker image into Artifactory. Once this is done, you can come back to X-ray, index resources, and select the specific Docker repository that you have recently created to be scanned by X-ray. Once you have enabled these scans, X-ray will be performing a continuous and deep recursive scan and make the scan results available under the X-ray scan list option. Here I'm going into the Docker registry, and I have a sample Docker image called exposures and the latest version of it. I can see that there are various malicious packages detected, vulnerabilities detected, and exposures that are detected in the Docker image. If I click on it, I can quickly explore the SBOM. I can look at the security issues in terms of vulnerabilities. We also not only showcase the CVs, but we also showcase whether you are actually applicable to the given CV or not by detecting whether the vulnerable function has been exercised, by detecting whether the networking port on which the given library is running might be masked by the firewall, for example. So depending on the CV and the attack compromise conditions that are needed, we will validate those conditions to tell you whether you're actually applicable for the CV or not. In this way, you can reduce the false positives and focus on the alerts that you need to pay attention to in the first place. I'm not going to bore you with all the tabs here, but our focus today is on the secrets detection. So if I click on the sample alert on the secrets detection, here I can see that there's a secret detected under the subfolder with the specific line number where the secret pattern has been detected. You can see the pattern is so-and-so, which is common across all the GitHub secrets. Similarly, for all the AWS secrets that are detected on line number 1, you can see the pattern that has been detected. So you can see what does it mean. So your organization is exposing an API key to the public world. So you need to take care of it, and this can be shared across multiple devices so the attacker can gain access to them. So what can happen? We also give you a sample story around a recent attack or a trend that we see with this kind of a token being compromised, what can happen and what are the potential implications associated with it, and what you should be doing. You should immediately revoke the token and alert your relevant teams. If possible, bring back the given Docker container from the production or relevant staging environments and fix it by removing those secrets. Follow a good practice of using a secrets management tool like HashiCorp Vault, for example, or AWS KMS tool in order to manage the secrets and provide these secrets in the runtime to the given utility rather than actually embedding the secret into the binary. So this is how we'll be able to give you the remediation technique as well. Now, I have various other similar alerts as well, and the relevant remediation techniques available that you can also explore it offline. Now, in summary, today we have looked at the JFrog platform and the powerfulness of it. Now, you might have a question, how is this possible? We actually take care of various feeds and we scan the secret patterns that various public cloud providers or various DevOps tool platforms, integration tools, alerting tools follow, and we maintain the database around it. We also test our path pattern detection mechanisms around various publicly available OSS package feeds to constantly benchmark ourselves whether we are able to comply with these recent changes or trends in the secret patterns, and our detection mechanism is up to the standard to your expectations. And at the same time, if there are any active, inactive tokens that are found with enterprise organizations or public projects, we immediately disclose them responsibly as a security research team and an approved CNA who can publish new CVs into the NVD database. We actually contribute back to the community as well. So you can also stay tuned to these alerts and findings by subscribing to our blog field. We will be posting the link on our security research team's webpage, and you can subscribe to Twitter as well as Slack alerts or email alerts whenever we have a new finding. So we completed this demo. I would like to use this slide to summarize the JFrog platform capabilities and the way in which it performs the software supply chain security. Here, the white dotted lines represent the regular CI/CD DevOps workflows that you might have in your organization. The green dotted lines represent the universal integration capabilities that the JFrog platform provides. So here, we are able to tap into every information source in your organization, and we are able to find out the metadata and give you the visibility and traceability into what set of dependencies are being utilized in the prod, what set of dependencies are being declared for the first time by your developers, what set of dependencies are entering your organization through the version control system and CI/CD packaging feeds, and at the same time, X-ray by natively integrating with the artifact source, we are able to provide you with impact analysis. Which team, which technology, which application, which environment is being impacted by the given vulnerability. So this slide actually summarizes the differentiators as well. So if you look at the entire DevOps workflow, the binary is the actual entity that actually traverses through every DevOps lifecycle stage, like starting from build, test, deploy, monitor, and scale. Every stage in the DevOps, the binary is the actual entity that is getting exercised and that is exposing your application to your public customers. So by being a binary focused solution, we provide you more in-depth analysis and give you information around what are the potential issues, vulnerabilities or weaknesses or secrets that are detected, or application service misconfigurations that are detected that you can be compromised through. And we also maintain the metadata around every alert. So we give you information on the impact analysis with the insights on what environment this alert has been detected. We have a very fine granular policy engine that can control the end-to-end software supply chain security. So you can have a dedicated policy for your developers, dedicated policy for your production deployment teams. Okay. So I would love to spend the next 5 minutes on any Q&A that you might have. You can paste the questions in the chat. We'll be happy to answer them. So I see a question in the chat on what packaging technologies that X-ray supports. Artifactory as a binary repository solution supports 30 plus packaging technologies. X-ray supports 18 plus packaging technologies as a part of the scanning coverage. We are expanding on more packaging technologies as well. Recently, we have added support for Terraform infrastructure as code scanning. We have added support for Rust Cargo, for example. Swift is the newest packaging technology for Artifactory repository support as an example. So the next question that I have here in the chat is, how frequently is the path pattern updated? So for the secrets detection capability in specific, as I mentioned, there are 80 million plus packaging feeds that we already scanned, and we have a database and pattern detection logic applications that we have developed for each time whenever there's a new set of secret pattern that is being released by a given platform provider, we get automated alerts and we try to understand the pattern and develop the logic. The central X-ray database updates itself twice in a day. The X-ray business logic or whatever the proprietary technology that we use gets updated once in every 2 weeks. That's the frequency of release that we have on X-ray side. So depending on how frequently the tools are updated as well as how frequently the database is updated, you will be getting this newest set of technology patterns as soon as in a couple of days once a new pattern is available. So I see that we are on the top of the specified time for our presentation today. Thank you all for joining me today on the webinar series on secrets detection. Looking forward to our next webinar series on the contextual analysis tomorrow. See you all.